Number 12, an absolute value. Remember, there's always two solutions there. It equals 2n minus 14. Now, normally there's two solutions, but when I see this set equal to a variable on the right-hand side, that tells me there might be a solution that doesn't work, an extraneous solution. So let's see. We know an absolute value can either be positive or negative inside that. So the n plus 2, just assume that be positive, could equal to 2n minus 14, or the other option is the opposite of that n plus 2, could be a 2n minus 14. So we're going to have to do both these, find the n's and plug them back in to see, do they both work? Only one of them work? Let's see what happens. So I subtract n from both sides. I get 2 is equal to, n minus 14. Move my 14 over. I get 16 as one of my solutions. I will plug that back in a minute to see, does that work? Here, no sense in dividing by -1 because it'll just move it over here. So go ahead and just distribute it through. And you can always distribute it through. I'm going to go ahead and I'll move my n over. I'll just add in. As long as I get all variables on one side and numbers on the other, I'm good. Now let's move the 14 over, add 14, add 14. We get a positive 12 is 3n. Divide by 3, n is going to be 4. We need to check because one of these might not work. If I plug 16 in, what's 16 plus 2? That's 18. Absolute value of 18 is going to be 18. 2 times 16, 2 times 16 minus 14. Well, 2 times 16 is 32. 32 minus 14 is, guess what? 18. 16 works. He's good. 16 is good. Let's erase these guys up here and try our other number. Trying to erase. There we go. So 16, whoa, doggy. So 16 works. So we know 16 is good. So 16, check. Let's plug 4 in. 4 plus 2 is 6. Absolute value of 6 is 6. All right, what about here? 2 times 4 minus 14. That's 8 minus 14. That gives you -6. -6 does not equal 6. That was an extraneous solution. N equals 4 is not one. The only solution we should have put on our page was n equals 16. This doesn't change much. We do need to read this. There's going to be two parts. It's a less than, because you would read blah is smaller than 11, less than. Okay, so it's going to be a less than. So it's going to be a less than, meaning an and, right? So it's an and. So we have 2n plus 1 less than, woo, she is messing up today. Sorry about that. Less than 11, okay? Less than, so this is an and. We have the opposite, the negative piece, less than or equal to 11. And what we will always do is we will come in and divide by -1 to get rid of this. Don't know why the board's doing it. I'm sorry, what's happening is it's grabbing it. Would erase, but we don't have time. So let's do that. Let's go to pen. Let's hope we don't have any more mess ups. Those divide. I end up with 2n plus 1. The sign will flip because we divided by a negative, and I get -11. That is always going to be the situation. You're always going to end up with your piece that's inside the absolute value. The sign is always going to flip. You're going to be -11, but I think it's important we show that step. So let's just solve both and we'll be done. -1 minus 1, 2n less than or equal to 10. Divide by 2, divide by 2. N is less than or equal to 5 is one possibility of our solutions. -1 minus 1, 2n. It is loving to mess up now. We end up with 2n greater than or equal to -12. Divide by the 2. You're going to end up with n is greater than or equal to -6, and this is an and I'm fine with you putting it that way, though really the best way would be like this, where n is between the -6 and the 5.